invented touch screen mobile. So this includes the exploration of the ideas. What is visualization? Visualization is the ability to mentally picture things that do not exist. We should visualize that those things which do not exist and we want to design those things. So visualize is the first step to engineering graphics design process. What is the next step? The next step is sketch. If we are we have explored the idea, we have visualized something, but we need something on the paper, so we need those sketches. To draw the sketches, what we need to do? Draw, design and record those initial ideas. If we are having any sort of idea in our mind, we should directly record to the paper, so our mind cannot forget those ideas and we are having those things on our paper. What is the next step? The next step is geometric model. After we have implemented those initial ideas, we need to have some geometric model to our hand. How we can achieve those geometric models? Those geometric models can be created from sketches, or we can analyze those sketches and we can do geometric modeling. In this portion, we need to have communication to the team. If we are having good communication, then communication would be better. The design solution should be communicated to the others without ambiguity. We need to give those communication and those design to the team member without any delay. Final one is detailed drawing and 3D models. What we are having detailed drawing, we need to have vast number of drawing. We should refine those things and we should optimize and record the precise data for production process or the implementation. It consists of all the detailed drawings. If we want to produce any sort of part, then what should be the tolerance, what would be the raw material to it, all those things should be covered in this detailed drawing. And 3D model is again for those person who are having technical knowledge. So with using those 3D drawing, they can see that what their final product looks like. The detailed drawings and 3D models consist in the documentation. We need to store those record for the solution. Now again it's having one example to it. Now as you can see that in this map we are having a river passing through the map, but on this river we do not have any sort of bridge. So we have something visualized, but what we have done, we are defined the problem. We have defined the problem definition that we want a bridge to pass this river. So what I have done, I have drawn my visualization into a sketch. I have drawn sketch of it, that this is the width of this river and what is the maximum width of the river. I have sketched it out. Next is exploration of the ideas. Now I know that I need to design a bridge over this river. Now I need to explore the ideas, that how many types of bridge we are having in this world, which would be the better bridge to build on this river. So we need to explore, either I will go with this bridge or this bridge or this bridge or this bridge or this kind of bridge. We need to explore our ideas. After exploring our ideas, what we are going to do? We are going to sketch. We are going to sketch our ideas and we will do design of it. We have concluded that yes, I want I want to have this cable stayed bridge. Now if I have completed this, I want this cable stayed bridge. Now what I need to do, I need to design those bridge using any sort of software or manually. We can design those things. After I complete this sketch and completing the design, what I am going to do, I am going to analyze those things. Bridge is very much important thing. So many vehicles passing through it, so we need to check that whether it can resist all those load or not. So we need to analyze the bridge capacity using the analysis software. After completing analysis, and if we found okay that yes, this bridge is very much okay, and we have analyzed those things, now what we are going to do, we will make detailed drawings of it, every single detail. To implement the construction of the bridge, we will refine and optimize all the things so that we can get the best out of the available resources. And finally we will implement our idea into reality. So the whole process is step by step process. Engineering design process comes from our idea. When our idea come to the implementation, our design process is completed. It's a step by step process, and we can do designing like this. Now if we want to design these kind of things, we need some standard. We need to have some standard. I am working in the India, someone is working in the US, someone is working in the Britain, but if we are using some sort of different things, I am saying 1 in US, the 1 means 10. If that those 10 means 100 in the Britain, then what would be the thing? We cannot implement our visualization into the reality. To implement all the things, we need to have a specific standard to implement all those things. If I say 10 gram, then it should be universal. 10 gram is universal in whole world. If I say 1 kg, then it's universal in whole world. If I say 1 feet, then it should be universal in whole world. So this is how a standard should be specified, that using what standard we are drawing and using what standard we are designing. Every country is choosing different standards. Let's say that India is using MS system, whether using US is ANSI, Britain is using BS. So we should implement proper things and proper standard step by step using the country. All those basic standard are same, only the difference between the conversation. Now why the standards are necessary, we'll see a video of.
There's 2 different projections that are common. We have the first angle and the third angle projections. Third angle projections are the ones we use primarily in the United States and Canada, whereas Europe and Japan use the first angle projections. And the way these projections are is just a way that you're trying to take a 3D object and display it on a flat surface, such as your computer screen or in a drawing format. So let me explain what these are. The book doesn't explain it as well as I think it probably could, and it's probably helpful to have something that's a little bit more visual. So I'm going to take a stab at this. So what you're looking at is a symbol up here. I drew this in a sketch format in SolidWorks. What you're looking at on the top is a third angle projection, and what you're looking at on the bottom is a first angle projection. Remember the third angle projection, that's a test question by the way, that's what we use primarily in the United States. That's the one on the top. So if you think about this, these are just symbols, and what we're looking at is a truncated cone. We're looking at a front view of a truncated cone, so the cone is kind of laying down. If you're thinking about gravity, it's kind of laying down and looking at us. So here's the truncated portion of the cone, and then the back part of the cone. And if you look at the right side of that cone, this is what it's going to look like on the right hand side. So in regard to projections, the third angle projection, if you think about this as a fold line, and that's the same for the first angle projection, you think about this as a fold line, the third angle projection, you're actually folding this part over here, you're folding this down. So if you fold this down, that turns into the right view. It will always be the right view, whether it's first angle or third angle. It just depends on where you put it. But this is the right view, and if you fold that down, you can see how that works. So with the first angle projection, it's a little bit different. You think about this as being a fold line, and here's your front view. What you're going to be doing is you're going to be folding this not down. You're not going to fold this down on that line, but you're going to fold that up, and that becomes the left view. But the way it works in projection is that the left view is going to be put on the right side when you have that either viewports in a drawing format or in a part format, but in a drawing format it might be the way it's laid out on the page. And in the third angle projection, this right view is going to remain on the right. So to help explain that a little bit better, let me go back to my model here, and I'm going to turn on the loft that I have. If we go to our view orientation, let's go to an isometric view so you can see what we're looking at here. And this is based not necessarily on the sketch I just drew, but it's got the same dimensions as the sketch I just drew in order to show the different projections. But I'm going to show this in a little bit more of a visual format. So here's our cone. And if you hit the space bar and go to our different views, this would be our front view, which would be consistent with and I'll bring over a PDF document of that of the sketches I drew. This is consistent with this view over here. That's our front view. If we hit the space bar again, over here, we hit our space bar, we're going to go to the right view, and this is also consistent with our PDF document that we drew, and that is the right hand side. That's the right view. To make this a little bit more visual too, I'm going to go to my display style, and I'm going to go down here to hidden lines removed and just repeat that same process. So that's going to be our front view, space bar. That's going to be our right view. Now, this really only becomes apparent when you want to do viewports. We don't do viewports very often, at least not in my class, not in SolidWorks. But if you want to do viewports, that is an option under view orientation. If you go to view orientation and go to the four viewport, the four view viewports, now you can see how that works. So here's our front view, here's our right view, and our top view. And again, let's think about our fold lines. This is going to be our fold line. We're going to take that front view, we're going to fold it down, and this is on that line, and this gives us our right view. This is again another fold line, and that gives us our top view. This is folded down, and then we have our trimetric, bimetric, or isometric up here, up in that corner. What makes this different is in the first angle projection, it's just a little bit turned around a little bit. Easy to follow, but it's just a little bit different. So let's go to our options. What you want to do is you want to go to your system options down here, go to display selection. And down here it gives you the opportunity to change that between first and third angle. We're going to change that back to first angle, go to OK. Then we're going to have to go back to our view orientation and go back to the single viewport. And then we're going to go back and do the four viewports. And now the views are just put into a different location. The fold lines are the same. If you think about this being a fold line between the front view and what's going to be the left view, what you're going to do is you're going to fold this up. And that makes this consistent with the left view. It's just that that left view is not on the left of the front view. It's going to be on the right. Think about this as being your fold line for the first angle projection. Instead of folding that down like we did in the third angle, this gets folded up. So now that becomes consistent with top view. Instead of the top view being on top, as we would consider the orientation of the piece of paper looking in front of us, and on the computer screen, it's actually on the bottom. And then our isometric, bimetric, or trimetric view is over here on the bottom right-hand side. So I hope that helps. Again, if you want to change the orientation here, go to your options button on your menu bar. Make sure you're in system options, go down to display selection, and change it from first angle to third angle. It is an option on the very bottom. So I will have another video here in a few weeks when we get into drawings, and I'll show you how to do this again and what the impact is when you put these into drawings. But I hope this was helpful, and we will talk to you in a different video.
Now we will see the standard definitions. Now we are having some sort of drawing standard to set the rule how we can present the technical drawings. Drawing standards are used so that drawing can convey the same meaning to everyone who reads them. Again, when I say that this drawing standard conveys the same meaning to everyone, which means that if the drawing is converted into the then they can concern the to everyone. It do not say anything else. There are few countries using some different standards. USA is using ANSI, that means that American National Standard Institute. Japan is using JIS, Japanese Industrial Standard. UK is using BS, British Standard. Australia is using AS, that's Australian Standard. Germany using DIN, that's Dutch Institute Normung, that's DIN Standard. And last one, ISO, International Standard Organization. When we see different countries using different standard, which means that they are having some sort of minor changes. In the ANSI system, they are using In the Japanese JIS, they are using inches. When British standard consists of the pound and the feet. Australian standard again using the ANSI. DIN standard again consists of the feet. ISO is common for the all. In the ISO standard, we are using basic as our main primary object. Now we have seen what are the different standards. Now we need to check what kind of different instrument we can use to draw the drawings. Which instrument used in the engineering graphics? These are the instruments. What are the objective of the drawing? Instruments. First, for the accuracy. Second is for the speed. Third, for the legibility. And fourth one is the neatness. If we are using good sort of instruments, then we can have four characteristic to our drawing: accuracy, speed, legibility and the neatness to our drawing. The figure shows the basic overall equipments which are used in the engineering graphics. Now we will see step